Good. Welcome back. Lecture number 1, Introduction to Electricity Markets. I would say this is maybe the most basic introduction to electricity markets. Maybe the content is trivial for many of you. So, yeah, but we need to make sure that all of us, we have the same understanding about the most basic things of electricity markets. So from the next lecture next week, we will add a bit of more complexity. But let's start with the most basic introduction. Good. So electric power systems, if you have a background in electric power systems, I suppose you already learned that there are 3 main gradients in power systems, including generators, transmission and distribution system, and then demands. Well, of course, there might be more ingredients in more advanced power systems, but this is the most basic one. And when we are talking about generators, we are talking about conventional and renewable generators. Renewables like wind farms, solar farms, hydro, conventional units like, I don't know, gas-fired power plants, coal-fired power plants, and etc. Then we have transmission system, high-voltage transmission lines, then distribution system, mid-voltage and low-voltage distribution system, and eventually the consumers. That's the most basic ingredients of power systems. So traditionally, we can think that there are 2 ways to organize this, run the electric power systems. One is a centralized way, centralized power systems, wherein there is no market. And the other one is the way that we can call it electricity market, running the electricity system through markets. In the first one, centralized power systems, when there is no market, there is a single entity, we can call it system operator. And the system operator is responsible for making all operational and planning decisions for the entire power system. I mean, having market doesn't mean that we don't have system operator anymore. Still, we have system operators. Do you know who is the system operator in Denmark? What's the name? Energinet. Energinet is the system operator in Denmark. And in the next lectures, you will hear a lot me talking about Energinet. Okay? But if we don't have any market, if we have a centralized way of running the power system, the system operator makes all operational and planning decisions of the system. So when we say operational decisions, what does it mean? Can you give me examples of operational decisions? And also people online, please feel free to write in chat box. Yes. So you mentioned about dispatch of generators. What does it mean? Anyone else? A schedule or dispatch of generators. Yes? Exactly. So for a specific time period, for example, tomorrow 2 to 3 p.m., how much every generator, either conventional or renewable, they should produce. For example, saying, okay, generator X should produce 20 megawatt from 2 to 3 p.m. tomorrow. That we call it dispatching or scheduling. Okay? That's operational decision. Can you give me another operational decision? Any other operational? Yes? Yeah, curtailment. Sometimes, for some safety reasons, you may have to curtail load, cut the load. Of course, it's a very extreme, harsh how to say, measure. But sometimes you may realize that you have no other option than that, curtailment of the load. So we are going to see more and more operational decisions, but you can feel that operational decisions are decisions that we take in real time or for the close future. For example, for the next day or for the next hour. Clear? The other word that you will hear a lot is planning decisions. What are planning decisions? Also, you can, if you like to make it the full name, it's a long-term planning decisions. Yes?
You build more lines.
Exactly. Transmission expansion planning. For example, what new lines we have to build, or maybe the lines are already there, we like to increase their capacity, right? That's a planning decision. Can you give me another planning decision? Frequency control. Is it for long term? If you're talking about reserve expansion for 20 years, make sure that in 20 years we have enough reserve capacity. That's for sure planning decision. Planning decision. Or generation expansion planning, right? So for example, you have estimation how much demand will be in 10 years, in 20 years, in 2050, and how to increase your current generation capacity to reach that level in 25 years, for example, right? We call them planning decisions. Good. So now we talk about system operator, no market yet, and this system operator make all operational and planning decisions. It's like a system without any market. There is one, it's a monopoly decision. System operator makes all decisions. So if you are that person, system operator, what would be your objective and what would be your considerations? You can schedule dispatch generators in a million different ways, but you are going to pick one. What pick one? Which one? Yeah. Social welfare is a market term. Here we don't talk about market at all. Minimizing cost. What cost? Yeah. The cost of the operational cost of the system. You want to minimize that. But if you like to minimize the system cost, what is the main system cost? It's the fuel cost, right? The cost of generators. If you don't produce at all, the cost is zero, minimum. Do you have any extra considerations or constraints?
I would say to balance the production and the consumers so they're both happy.
Very good. So you want to supply demand in the minimum cost. Do you agree with that? It's not market yet. There is no market. We have some specific demands. We can make all decisions for generators. All of them, they belong to us. So what is our goal and consideration? Yes?
Goals to securely supply electricity to all the consumers by being cost-effective and sustainable.
Very good. When you say securely, what does it mean? So that's the balancing power, the production and demand, right? So you're correct to meet the entire demand by dispatching power generators across the network in a feasible and cost-effective manner. So we like to make sure that we dispatch generators in a minimum cost. So it's optimality. Then the second word here, there are two bold terms, feasibility and cost-effectiveness. Feasible. What does it mean? Is there that we may have a schedule which is not feasible? Yes? Yeah. There are many ways that there are many constraints that you should take into account. For example, one is transmission capacity. If, for example, the capacity of line from point A to B is 100 megawatt, then you cannot transfer 200 megawatt there, right? It's about feasibility. Or other feasibility is, for example, there are, if you have a power system background a bit, there are voltage constraints. There are, I don't know, reactive power constraints. So, it's a bit complex machinery, the power system. You have to make sure that different constraints are fine. Also, security that one of you mentioned is also about feasibility. For example, what is security? One of the famous security criteria is called N-1. Have you heard of that? N-1 says that we schedule the system in a way that if one line or one generator is out, still demand can be supplied. It's the very basic. So we have to make sure that, okay, I'm dispatching generators like this, but if generator number X is out, still I'm fine. It's about security. So when we say feasibility, we are talking about all these considerations. Security considerations and physical constraints. When we talk about cost effective, we are talking about cost minimization. Let's say that we have two solutions, two potential solutions. All of them, they satisfy feasibility. All of them, they satisfy demands. But then we are going to pick the one that incur less cost for us. Is it rational? Good. That's what power system operator tries to do if there is no market. Now let's think about market. Now here, the power producers, they don't necessarily belong to one entity anymore. They may have different owners. For example, in this very basic example, imagine the green renewable wind farm. It belongs to producer B. I don't know, the power plant red, it belongs to producer A, while producer C owns two types of plants, power plant conventional and renewable. By the way, now that you are in Denmark, can you give me some developers, name of some famous power producers in Denmark, active in Denmark? Vestas. Vestas is a manufacturer. They are building farms. Ørsted, that's the biggest power producer in Denmark. Anyone else? European Energy. Yeah, true. RWE, yes. Okay, there are many, and you see that they have different portfolio, and they are selling their power. They have different owners. So, if this is the setup, so can you tell me that if you are the owner of, if you are the producer B, you are the owner of this green renewable, what will be your goal? Is it still minimizing the system cost, feasible, cost effective, or will it be something else? Yes? The maximize profit. Profit is the term that now we hear for the first time. All the course is about profit. You are going to calculate a lot of profits in your assignments, I can tell you. So each producer aims to maximize their own profit by making optimal operational and planning decisions. Still, operational and planning decisions, they are the same decisions, but to be made by producer B. Is transmission expansion planning a planning decision for producer B? Is it? No. It's now decision of system operator. So what is the planning decision of producer B? Can you give me an example? For example, it's expanding the capacity, the portfolio. Having one wind farm, having, I don't know, electrolyzer, having, I don't know, some conventional units. That's the planning decisions of producer B. So unlike centralized setup, now we have multiple decision-making involved. So it's not one decision maker anymore. There are different producers, different consumers, system operator, they're all making decisions. Are their decisions separate or interacting to each other? What do you think? They interact each other. So all of us, we make decisions, while our decisions, they impact each other. Have you heard of something in mathematical science, maybe? That everyone making its own decision, maximizing profit, while these decisions impacts each other? Game theory. Game theory. Game theory says that here we are 150 people. All of us, we make our decisions, but our decisions are not independent. For example, there is a demand of 100 megawatt. All of us are generators, and we want to supply that. Then we are competing. That's a game. So that's why electricity market, it's a game theoretic problem. You are going to learn about game theory in this course. Have you watched The Beautiful Mind, the movie Beautiful Mind? John Nash, who contributed a lot in the field of game theory. If you didn't, maybe you want to watch it. Good. So how can an electricity market be operated if we have multiple decision makers? All of them, they try to maximize their profit. How? So here we have a very a bit funny example, Apple market. Let's understand how Apple market works, how we can design a platform to trade apples. It's a very basic, naive example and funny example, but we are going to extend it to electricity market, okay? And by the way, please listen carefully, because at the end we are going to have a Kahoot test. Then you will see how much you'll learn. It may look simple, but sometimes you will see from the questions that questions could be tricky. Good. Imagine that we have 3 Apple sellers, seller A, B, C, in different colors. Say seller A sells 2 apples at the price of $1 each. It's the seller with the least cost supply. Seller B sells only 1 apple, but at the price of $2. Seller B sells 3 apples at the price of $3 each. So the quality of apples are exactly the same. Just seller C is more expensive. Is it okay? Clear? So then we can plot a curve like this that we are going to call it supply curve. You are going to hear a lot in this course, supply curve. And supply curve is a non-decreasing curve. So it's not decreasing, it's non-decreasing, that we rank sellers based on the least cost. So the cheap supplier first, and then until we put the last supplier, seller, which is more expensive. And we are going to call it merit order principle. When you heard merit order principle, it means that we rank suppliers or later consumers based on their cost. Is it clear? Easy, right? Also think that we have 3 buyers. Here, arbitrarily, we said 3 buyers, but it could be a different number, 4 buyers or 1 buyer, whatever. So buyer A buys 1 apple at a price of $6. So buyer A is willing to pay the most to buy maximum 1 apple at price 6. If the apple price is 7, the buyer A will not buy. If it's 6 or less, it will buy. Is it clear? So what is this $6? Can you interpret that? So buyer A is willing to buy 1 apple at the price of $6. If it's even less than 6, even better. So what is $6? Marginal what? Not marginal demand. It's the utility. It's the value of apple for buyer A. Maybe buyer A is going to use apple for a different purpose, and the value of apple for that buyer is $6. It's called utility or value. Then buyer B would like to buy maximum 1 apple at the price of 5. And buyer C likes to buy maximum 2 apples at the price of 4 each. Clear? Again, we can plot this curve that we are going to call it demand curve, which is a non-increasing curve. We put buyer A first, 1 apple at price 6, then 1 apple at price 5, then 2 apples at price 4. Is it clear? So now we have demand curve and supply curve. Now that we have both curves, let's determine their intersection. Are you familiar why we are trying to find intersection? How many of you knows that? Okay, almost half of you. So can one of you tell me why we are interested in finding intersection? Yes? Good. We like to find the equilibrium price. Let's see what it means. That's correct. So we put these two curves together and find the intersection. Whenever you do this, what you do is you clear the market. You are doing market clearing. So when you hear market clearing, it means we have supply curve, we have demand curve, we put them together, we find the intersection. Okay? So in the assignments, I will ask you, determine market clearing price and quantities. It means you need to do that. Who does that is a third entity called market operator, and that entity is nonprofit. It's an entity who is not seeking for profit. Is it clear? Who is the market operator? Can you tell me some market operators, electricity market operators? For example, the one in Denmark? Nord Pool. Anyone else? But now it's not just Nord Pool. There's no monopoly anymore. Have you heard of any other electricity market operator? Yes? Apex is a French company. Yeah, you will learn a lot about these things. Okay. Market operator, that's a word we learned. Okay. Now let's understand why we are finding intersection. The next 2 slides are about why we find intersection. To do that, tell me, what is this blue area? I mean, it's written, but what is that? It shows the total value of apples for 3 buyers. Remember, buyer A is willing to pay $6. Buyer B is willing to pay $5. Buyer C is willing to pay $4 for each apple, so 8. 8 plus 5 plus 6, it's 19, right? $19 is the total value of apples, the total utility of 3 demands. Is it clear? Similarly, what is the pink area or red area? Is the cost of producing apples. So here we make an assumption that every seller, they announce their true cost of selling apple. It means that when seller 1 says that I'm selling 2 apples at price 1, $1 is the true cost for seller A to produce that apple. It's an assumption that we are taking for now. Is it clear? So if we say that, what is the red area? It shows the total cost of producing these apples, right? So for producer A or seller A is $2. For seller B is, it's 2 or 3, I forgot. I think it's $2. And for the last one is $3. 3 plus 2 plus 2. Is it clear? So, what we are interested, that's a new term you'll learn. Again, in your assignments, I will ask you, calculate social welfare or surplus. They are the same things. The social welfare is the orange area, the area between supply curve and demand curve. So before me explaining further, we are interested to, even before saying maximizing, we are interested in calculating the orange area, the between area. Do you have any idea why, based on the last two slides I showed you? Why we are interested in calculating social welfare? Yes.
How much money consumers would save?
Yes. What about, so you're saying you like to see how much consumers they save. What about the generators? You are not interested in generators? Oh, yes. It shows how much more generators could earn. Yeah. Look at the word social welfare. We are talking about society. Is only generators or demands our society, or do we need to consider both? Both. So now can you interpret social welfare in a way that both of them are involved?
How much value the society is getting from
What do you mean by society?
I mean the economic actors are obtaining for this concept.
Okay. Good try. A bit more. One more try. Yeah, please. How much less consumers should buy? Okay. Yeah. But what about generators in your definition? Yeah. I think you're close. Okay. Let me help you. You remember the blue area under demand curve. It shows the value of apples for 3 buyers. It was $19. Do you like to increase it or decrease it? It's the value for demands. You like to increase it. It shows the value of apples. Okay, remember that. You want to increase the blue area. The red area, the cost for sellers to produce apple. Do you want to increase it or decrease it? Decrease it. You want to expand blue. You want to decrease red. Can you combine them? What are you then trying to do? You try to expand this orange area, right? If you expand the orange area, at the same time you are trying to maximize value for demands. At the same time, you are trying to minimize the cost for generators or sellers. So when you are maximizing social welfare, you are doing both. You are doing a favor for both sides, maximizing utility for demands, minimizing cost for generators. You are pushing the blue part to be increased and decreasing down the red area. Am I clear? Or do you want me to explain again? So social welfare is a very interesting measure. We want to maximize it because when we maximize it, both suppliers and demands, they are happy. Right? So by maximizing social welfare, the total value of commodities, like apples here, for consumers is maximized. The blue area is maximizing. The total cost for suppliers is being minimized, resulting in satisfaction of both demands and suppliers. Okay? So, intersection. We are interested in intersection. Why? Because in the intersection, the social welfare is maximum or minimum? Maximum. Remember, this is the social welfare. And here, if we pick this point, then the social welfare is the maximum. If, for example, you pick only 2 apples, then the social welfare is this area. Then social welfare is less. We try to get the maximum social welfare that we can get. Clear? For given supply and demand curves. So that intersection, we are going to call it equilibrium point. Equilibrium point. Do you know where equilibrium point, the term equilibrium point comes from? From what field? You just mentioned. No, yes, economics, but it's a term for games theory. Have you heard of Nash equilibrium? I'm going to talk about that. And the movie I told you, Beautiful Mind, is about the life of John Nash. Nash equilibrium point. I'm going to tell you about Nash equilibrium point in lecture 3, I guess, or 4. I don't remember. But Nash equilibrium, just to give you a teaser, is that a point that if all of us, we are happy there. If we change our strategy alone, we are going to lose. So it's a point that everyone is okay with that. That's the equilibrium point. Why, I will tell you in lecture 3 also from games theoretic perspective. So that point gives you the market price, market clearing price, and market clearing quantity. So what is that? So now what is the corresponding price here? It's blah, 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 $3. The market clearing price is $3 for each apple. Market clearing quantity is 4. We are trading 4 apples. Clear? At this point, the social welfare is maximum. Based on, remember, what I'm telling you is based on a pricing scheme called uniform pricing. Also, some people call it marginal pricing. So when I'm saying uniform pricing, I'm talking about marginal pricing. So uniform pricing, it means that there is a uniform price for everyone. There is a common price for everyone. And here is $3 for each apple. Is it clear? So tell me, buyer A, who wanted to buy apple at price 6, at what price you are going to charge that buyer? 6 or 3? 3. That buyer wanted to pay up to 6, but now the market says 3. You pay only 3. So $6 was the value of apple for that buyer. Now it's paying $3. What is the utility of that demand? Utility means how much the value was minus how much the buyer paid. 6 minus 3, 3. Is it clear? For seller 1, who sells 2 apples at, that seller wanted to sell at price minimum 1. Now at what price we are paying to buyer 1? 3. So how much we are paying to that producer, that seller in total? 2 apples at price 3. So, no, 6. 2 apples at price 3. We are paying $6 to that seller. What is the cost of that seller? 2. What is the profit for that seller? 4. Is it clear? Good. So based on uniform pricing, does any buyer or seller necessarily pay or receive the price they submitted to the market? Does it necessarily? No. Good. Good. There is another market pricing mechanisms that I didn't mention here. So uniform pricing is the most common one. Why it's very favorable, interesting, I will tell you later, not today. But besides uniform pricing, have you heard of any other pricing mechanism? Pay as bid. Have you heard of pay as bid? A few. So what I told you is uniform, one price for the whole market. But there is another one, another scheme called pay as bid. Pay as bid. So do you have any idea what pay as bid is? For example, if it was pay as bid, So to seller 1, the first red piece, what will be the payment? What price we are going to pay that seller? 1. So in pay as bid, we say, whatever you bid, we pay you that. Clear? You said 1, I give you 1. You said $2, I give you $2. You said $3, I give you $3. But in uniform pricing, we say, no, we pay everyone $3. We charge everyone $3. But in pay as bid, we say, oh, the first demand wanted to pay 6, pay 6. Clear? There are a lot of literature differences of pay as bid and uniform. What is good? What are their pros and cons? But I can tell you that most of electricity markets, most of them are not using uniform pricing for many good reasons that I will explain later. Okay?
Does this price goes the same for natural gas and other commodities?
Yes, yes. It depends which market you are talking about. But uniform pricing are being used not only in electricity market, but also for other commodities, including heat, gas, whatever. But it depends which country, which market we are talking about. But yes, uniform pricing is being used in many sectors. Yes?
I'm not entirely sure about the term utility, because in the first part you
Yeah, utility is like profit. It's good that you mentioned.
yes, but in the first slide you
Yes,
determined buyer's A's ability to
yes,
pay
yes.
$6 as his utility. So he would pay $6, which is fine, but
Yeah,
it's utility.
very good. For example, for this one, this is the value of Apple for that buyer. So $6 is the value. How much is the maximum that buyer is willing to pay? Utility is, okay, I didn't put different color. Utility is this one. It's like a profit.
It always needs the supply curve as well.
Yes. Oh, sorry, I said wrong. Sorry. This is the market price. So this is how much I'm paying, and this is what is the value. So in your case, it was $6 is the value of Apple for me. I paid 3 because it's the uniform pricing, so it's not this area, sorry. So this $3 is the utility. It's like profit. The value of Apple is 6 for me, but I paid 3. So the other 3 is kind of a utility for me, a profit for me. Is it clear? The same for generators. This is the market price. Market price, $3. The $1 is the cost. So this is the cost. And this is the profit for that generator. Is it clear? So $3 the seller gets, $1 is the cost, $2 is the profit. Clear? Good. Let's move on. Electricity market is the same as Apple market, a bit more difficult, I will tell you. But in electricity market, now quantity is not Apple, it's megawatt hour. And the price is euro or DKK Danish krone or dollars per megawatt hour. Again, you have demand curve and supply curve. So can you tell me that what is the market price here under uniform pricing? It's around 40 something. And how much electricity we are trading? Around 1,000 megawatt hour. Okay, just for you to know that it's not, it's realistic, this curve. Let's check supply-demand curve in Nord Pool. Nord Pool is market operator in Nordic countries. You see the date on top? It's today, 3rd of February 2025. What hour? This is the first hour of the day in the midnight. Blue is the supply curve, red is demand curve. And that's for DK2, DK1. What are they? We are going to talk about in next lectures. But DK1 is Jutland area of Denmark. It's western Denmark. The price is 125 euro per megawatt. In Denmark, DK2, including Sjælland, it's Denmark. The price is 129.53 euro. Coming from this. So maybe I can give you a minute. You can go this link. You have these slides. If you don't have Google Nord Pool, or we can find together. Let's find together. Nord Pool. This is the Nord Pool website. You can go market data. You can come here, aggregate bidding curve. You can pick the area you want, Finland, Norway, Sweden, Denmark, whatever. Right now it's Denmark. And this is the supply-demand curve for what date? You can choose the date. It's for today, 3rd of February. And this is for different hours, hour 1, hour 2, hour 3. And you can see supply and demand curves. Is it clear? And the intersection of these curves for every hour gives the electricity price in that hour. Why in 2 parts of Denmark we see different prices? You are going to learn it in one of the future lectures. Is it clear? Do you have any question? Okay, so you see that in real life, the market, electricity market is being cleared exactly like that, based on curves. Good. Discussion. Please don't say next slide yourself. We talked about Apple market and electricity market. Yes?
I wanted to ask you a question regarding the last slide.
Yeah, sure.
So, don't we always try to produce as it's needed? So, in a way, the equilibrium point needs all demand, right? Like, with certain exceptions, we always meet the demand, right?
Yes. Okay, the question is that, by the way, that's a good point that you said. So here we said the market clearing price is here. So it means that all generators and demands in the right-hand side of the equilibrium point will not be accepted in the market. Because these generators are asking for a higher price, while these demands, you see my cursor, right? These demands are willing to pay at a less price than the market price. So the question is that, aren't we interested to supply all demand at any cost or not? We just only supply the demand which is until, which are in the left-hand side of the equilibrium point. Is the question clear? So here, based on this market clearing, we only supply around 1,000 megawatt, while the demand in market is about 1,200, 1,200s. Shall we try to supply all 1,200s or just the demand until to the intersection? Pardon me? Do we want to supply all demand? But here the demand in the right-hand side of the equilibrium point. Of course they are demand, but they are not willing to pay enough. Imagine that there are also a lot of demands, they are willing to pay only 0. Are we going to supply them? Is it a supply-demand, is it a free market? No. No. We should take care of both demands and generators, right? And we find the equilibrium point. We only accept demands and generators who are, from the generators, who are willing to sell until up to the price of equilibrium, and demands who are willing to pay at least the equilibrium point. If someone is willing to buy electricity at a price lower than equilibrium price, sorry, yes, you are demand, but you are not willing to buy at enough price. And the same for generators. Is it clear? By the way, I didn't mention you. For here, there are some generators. They are bidding at price 0. Who are they? Renewables. Their true cost, operational cost, is about 0. There are some generators that they are bidding a very high price. Who are they? Usually gas, if the gas price is high. But also remember, there is something called gas market. The gas market price influences what their bid is here. Good. Did I answer your question?
Yes.
Okay. Yep.
When they bid at 0, doesn't it mean that they can't make, like they make the profit because it's being bid higher, but in the initial buy of them, they do not count their own profits.
Very good. You are a wind farm. You know the market is uniform pricing. You know it. It's not pay as bid. It's uniform. Are you going to bid at 0 price or not? Why? Yeah. When it's 0, you always know that you are the first one who is selling, so always you will be dispatched. Are you going to be paid at price 0? Not necessarily.
But it's a rule for renewables, not for other generators.
Usually, in a perfect market, what imperfect market you are going to talk? In a perfect market, everyone bids their true cost as a generator. What is the true operational cost of demand? I'm not talking about investment. Operational cost of demand of renewables? 0. And they bid 0. Sometimes even they bid negative. Why? Sometimes you can see that renewables are bidding at price minus $5 per megawatt hour. Is the price, is their cost is minus 5? No, their true cost is minus 5. What is that? It's tariffs. Yeah, it's tariffs. Sometimes the government says that for any megawatt wind you produce, on top of electricity market price, I'm going to pay you outside the market $5. So the true cost is minus 5. Okay, I'm going to talk about those things later. It's too, you see, I'm very happy that a lot of questions raised. I promise many. I will answer all of questions in the coming lectures. Differences of Apple and electricity markets. Oh, don't see the answers. What do you think? Are they exactly the same or different? Electricity market also for economics are a very special market. They like it. Uniform, yeah, okay. Also, Apple market is uniform. What do you mean?
But there are different kinds of apples. There's different kinds of electricity.
You mean source of electricity?
No,
Power is power.
the power is power, but an apple isn't an apple. In our example, it was, but in the real world, it isn't.
Also, you can say electricity with different quality. Have you heard of power quality? Generators may provide power with different qualities, how much noise harmonics they have. Also, you can say that power is not the same. Let me, yeah. Yes. Electricity at large scale, I'm not talking about the small batteries, it's not storable, at least today. But you can store Apple, whatever, laptops. You can store it at least for some time until it's got rotten. But for electricity, you can't store it at least today. Yes, you can. If you have pump hydro storage, you can. Denmark is a very flat country. You can't. So electricity at large scale still is not storable. Of course, this is changing. How is it changing? Batteries. But batteries are small. Which battery, for example? Big batteries, okay. But when I'm talking about large scale, I'm talking about 1 gigawatt battery. Do we have it? Hydropower or pump, but it's not the case for Denmark. Yes. Hydrogen. You can store electricity in a different forms. You can convert electricity to hydrogen, green electricity to hydrogen through electrolyzers, or convert it to heat through heat pumps, whatever, and store that. Then you can use either as it is, or convert it back to electricity, but efficiency will not be good. Okay. Storing in a different form. That's why we also talk a lot about integrated energy grids or multi-carrier energy systems. Good. Any other example? Compressed air. Again, it's not going to be 1 gigawatt, I think. I'm not very expert in batteries, but I suppose it's not super big. Think of millions of small batteries. Who is bringing that? Cars, electric vehicles. Electric vehicles. The aggregator of EVs are gonna play a big role, hopefully. Good. Okay, back to differences. Apple and electricity. Electricity still is not that storable in that big level. Any other difference? We talked about Apple. Let's say that you produce it in Spain. You can bring it to Denmark as you like by, I don't know, trucks or ships or whenever time you want. Is it also the case for electricity? Can you order electrons to go from point A to point B? Can you do that? No. Why? There is underlying physics. There is a physics that govern power systems. You learned about Kirchhoff laws, right? The most basic. Electrons are being flowed in the lines based on KVL, KCLs, not based on power market outcomes. So your market clearing procedure should be consistent, should be aligned with the physical laws. Is it clear? Good. And the third difference I want to tell is that electricity demand is typically highly inelastic to price. For example, if the Apple price is, if you go netto grocery shopping and see that Apple is very expensive today, most likely you are not going to buy it, right? You can leave it later. But is it the case for electricity? You want to watch a very important football match, I don't know, Friday evening. You pay electricity at what price it is, unless it's super, super expensive. But most likely, so it's inelastic to price. People, they pay it no matter what price is. But this is also changing a bit by smart grids, whatever. Good. Okay. We are a bit beyond the time, but there is no 3 to 5 p.m., so hopefully it's fine that you stay with me 10 minutes, a quarter more. So what you are going to learn is that we have something called market clearing algorithm, which is finding intersection of demand and supply curves, finding the equilibrium price. The input to that gray box is offers and bids. Usually in electricity markets, when generators submit their wheeling price to sell and their capacity, we call it offer. While for demands, we call it bid. It's like what we agreed. So offers from conventional and renewables, it's their quantity, how much they are willing to produce in megawatt hour, and at what price? Danish krona per megawatt hour. For demands, it's bids, how much they are willing to buy, and at what price. The blue offers, by that we can make the supply curve. With this green information, we can build the demand curve. Then it goes to the gray box, market clearing algorithm. You find the intersection, and the intersection gives you the market clearing price and market clearing quantities. Means who produces, who consumes, but who have accepted bids and who doesn't have. Is it clear? In this example, it was 3 buyers, 3 apples. You find the equilibrium point simply by drawing. But if we have millions of producers, millions of consumers, can you do that by hand? It's not going to happen. You are going to need to write optimization problem, mathematical programming for the gray box. Especially if we have further constraints, like capacity line constraints, like many other things we will talk. You cannot do it by hand anymore. That's why we are going to have mathematical programs in the gray box. Clear? Good. Kahoot. So we have 9 questions. I suggest that here in person, if you like to make it more fun, maybe you can group in 2. While people online, if you are not sitting together, maybe you can join individually. Let me run it. It's the first time I'm running Kahoot, so hopefully I will not miss it. Okay. Yay. Okay. You can use this QR code, or you can go directly Kahoot and use the game pin. As I said, you can be in groups of 2. You can give a title to your group. Or if you want, you can join individually. It's up to you. And the same for people online. Oh, you are fast, guys. So what are the funny names I see here? Hello. So you are familiar with Kahoot, right? Also, speed matters, right? How fast you are also matters. "96 groups so far, 97. "103 groups, 104. Okay, 104 is the equilibrium number. You reach there. Oh, 105. Oh, 7. Wow. 8. Okay. I give 30 seconds more. 110. 109 now. Okay, let's get started. There are 9 questions. The earlier questions, you only have 10 seconds. Later, it will be 20. We start. Question 1. It's coming, hopefully. What is the social welfare for wow, 94 answers. 93. 93 correct. Social welfare is the area between supply and demand curve. Is it clear? Good. Next. So, not working is number 1. Good. Yeah. Are you ready for question 2? Question 2. At the equilibrium point, the social welfare is 89 correct. The social welfare is maximized. Very good. Still not working? It's working, actually. Whatever you do, it works, so keep it. Question number 3. Yes, which suppliers have an accepted bid in the market? The blue one was in the right-hand side. Only green and red, they were supplied. Sorry, the red and green. Good. Let's say Diego. Very good. Not working is now 5. Role is second. Tran is third. Crocha is fourth. Ready for the fourth one? Yay! 76 is correct. Remember, it's a uniform pricing. We pay people at the same price, 30 and 30. So, Goal is now fine, first one. Not working is back, third. Diego, second. Crocha and Albert. You ready for the fifth one? Payment and profit for green supplier. Yes, we have 45 groups correct. Remember, payment is $30 times 20 megawatts, 600. 400 is the cost for that producer, so the profit is 600 minus 400, it's just 200. So let's see. Role is still first. Next question. This is a tough one. You have 30 seconds. You have 30 seconds. Come on. So 22 groups is correct. 2,700. So the total area under demand is 4,200 minus 1,500 for generation cost is 2,700. Let's see how is the ranking. Wow, we have Hawk Jazz. Good. There are 2 questions left. Korean supplier under uniform and pay as bid. At what price they are being paid? 30 and 20, very nice. And the last question. Last question is multiple choice. There might be more than one correct answer. Okay? Heads up. That's the last question. Let's see. Jazz, very good. Not working, disappeared. Oh, it's not the last one. It's not multiple choice, sorry. Which one is incorrect? There is only one incorrect. Orange is correct. Actually, for consumers, it matters at what price Orange is bidding. If it bids at 30, the price is 30. If Orange bids at 40, the price is 40. So for consumers, it matters. Okay? You see, it looked a very simple lecture, but you can easily come up with tricky questions. Very good. Jazz. Manu, Diego, Lebron, and Matthew. This time is the last quiz, and it's indeed multiple choices. Multi-select. Very good. All except blue was correct. So Nord Pool publicly published, yes, you just saw it. Market operator is a nonprofit entity, correct. The intersection of supply and demand curve determine the market price, yes. A wind farm will never be that zero price. We just discussed that they can. So, number third, Manu. Number second, Tran. Number first, Diego. Who is the group, Diego? Group Diego? Are they here? Yes, you alone? Very good. Good, thank you so much, and see you next week. Please remember to form your groups. Thanks.